The next question is, you are given that the limit as delta x approaches 0 of the quotient of f of x plus delta x minus f of x minus delta x, all divided by 2 delta x, equals 3x squared minus the cosine of x. Find the differential of f of x. Let's work through this problem together, going step by step to make everything super clear. Our goal is to find the differential of f of x, and we're given a limit that involves the function f. It might look a bit tricky at first, but don't worry. We'll break it down into simple pieces, and by the end, it'll all click. Ready? Let's dive in. Step 1. Understand what the limit means. The problem tells us that the limit, as delta x gets very close to 0, of f of x plus delta x minus f of x minus delta x, all divided by 2 delta x, equals 3x squared minus the cosine of x. This limit looks like a difference quotient, which is a big hint that it's probably related to the derivative of f. Derivatives measure how a function changes, and limits like this often pop up when we're trying to find that rate of change. Let's figure out what this limit is telling us about f. The expression inside the limit is f of x plus delta x minus f of x minus delta x, divided by 2 delta x. This feels like it's measuring the difference in the function's values at points just to the right and left of x, scaled by 2 delta x. Let's explore how this connects to the derivative. Step 2. Connect the limit to the derivative. Usually, the derivative of a function f at x is defined as the limit, as delta x approaches 0, of f of x plus delta x minus f of x, all divided by delta x. But here, we have f of x plus delta x minus f of x minus delta x, divided by 2 delta x. The numerator involves points symmetrically around x plus delta x, and x minus delta x, and the denominator has a factor of 2. This looks like a symmetric difference quotient, which is a common way to approximate a derivative. Let's see if we can rewrite it to confirm this. Let's focus on the quotient. The expression is f of x plus delta x minus f of x minus delta x, divided by 2 delta x. Notice that the numerator is the difference between the function at x plus delta x and x minus delta x. The denominator, 2 delta x, suggests a scaling factor. Let's try to make this look more like the derivative by rewriting it. We can express the quotient as 1/2 times f of x plus delta x minus f of x minus delta x, all divided by delta x. Now, let's break down the numerator to see if we can make it resemble the derivative. F of x plus delta x minus f of x minus delta x. This is the function at x plus delta x minus the function at x minus delta x. Let's try to split this difference to align with the derivative definition. F of x plus delta x minus f of x minus delta x equals f of x plus delta x minus f of x plus f of x minus f of x minus delta x. So the quotient becomes f of x plus delta x minus f of x plus f of x minus f of x minus delta x, all divided by 2 delta x. We can separate this into two terms. 1/2 times f of x plus delta x minus f of x, divided by delta x, plus 1/2 times f of x minus delta x, divided by delta x. Let's look at each term as delta x approaches 0. The first term, f of x plus delta x minus f of x, divided by delta x. This is exactly the definition of the derivative of f at x, because as delta x approaches 0, this quotient becomes f prime of x. The second term, f of x minus delta x, divided by delta x. Let's rewrite this one. F of x minus delta x, divided by delta x. To make it look more like a derivative, let's set u equal to minus delta x. As delta x approaches 0, u also approaches 0, and x minus delta x becomes x plus u. So, f of x minus delta x, divided by delta x, becomes f of x plus u, divided by minus u, times minus 1 over minus 1, which is minus f of x plus u minus f of x, divided by minus u. As u approaches 0, f of x plus u minus f of x, divided by u, is the derivative f prime of x. So, minus f of x plus u minus f of x, divided by minus u, equals f of x plus u minus f of x, divided by u, which approaches f prime of x. Thus, the second term becomes f prime of x. Now combine the two terms. The limit is 1/2 times f prime of x plus 1/2 times f prime of x, which is 1/2 plus 1/2, or 1 times f prime of x, which is just f prime of x. So we found that the limit, as delta x approaches 0, of f of x plus delta x minus f of x minus delta x, divided by 2 delta x, equals f prime of x. Since the problem says this limit equals 3x squared minus the cosine of x, we have f prime of x equals 3x squared minus the cosine of x. That was a neat little trick. We've confirmed that this limit gives us the derivative of f directly. Now we're ready to find the differential. Step 3. Find the differential. The problem asks for the differential of f of x. The differential is simply the derivative times dx. Since we found f prime of x equals 3x squared minus the cosine of x, the differential is the differential of f of x equals 3x squared minus the cosine of x times dx. This seems straightforward, but let's make sure we're on the right track. Step 4. Double-check our work. Let's verify our interpretation of the limit to ensure we didn't miss anything. The expression f of x plus delta x minus f of x minus delta x divided by 2 delta x is called a symmetric difference quotient because it uses points on either side of x. This form is known to give the derivative directly, as we showed by splitting it into two terms that each approach f prime of x. If we want to be super thorough, we could use a method called Taylor expansion to confirm this, but our algebraic approach was solid and the math checks out. To make sure, let's think about what would happen if the denominator were different, like in your original problem, where it was f of x minus f of x minus 2 delta x divided by delta x, which gave 2 times f prime. Here, the 2 delta x in the denominator and the symmetric points balanced out to give f prime directly. So, we're confident that f prime of x equals 3x squared minus the cosine of x, and the differential follows naturally. Final answer is the differential of f of x is 3x squared minus the cosine of x times dx. Here are some key tips to make problems like this easier next time. 1. Spot derivative limits. When you see a limit with a difference of function values divided by delta x or a multiple of delta x, it's usually about the derivative. Symmetric forms, like f of x plus delta x minus f of x minus delta x, often point straight to f prime. 2. Rewrite the expression. Break the quotient into parts that look like the derivative definition. Here, we split the numerator into two differences to see that each became f prime. 3. Handle scaling factors. If the denominator has a constant, like 2 delta x, rewrite the expression as 1/2 times the numerator over delta x to simplify. 4. Use substitutions for clarity. For tricky terms, like f of x minus f of x minus delta x, try substitution like u equals minus delta x to make it look like a derivative. 5. Differential is easy. Once you have the derivative, the differential is just the derivative times dx. Double-check that your derivative matches the limit's value. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel and turn on the notification bell. Press the like button. Thank you so much.